See, using kinetic theory of gases, we should be able to predict or prove what is PV is equal to 1 by 3 mnc square. Average kinetic energy will turn out to be 3 by 2 RT, and RMS will come out to be root of 3 RT by M. Okay. We can derive that, uh, using this simple fundamental. Consider a particle present at one corner or on one face of a cube. From here, as it moves towards B and comes back. Okay, so this is one particular collision in X direction which it is making with the walls of the container. So considering this simple fundamental, we should be able to find out what is the pressure which is being applied by that particle on this face B. See, we can check out the momentum which it is carrying, before the collisions is m into ux. After the collision, it is minus mux. The change in collision would be 2 times of mux. Okay, so this minus of minus this, so that will be 2 times of mux. This is the change in momentum. And the distance traveled from A to B and coming back to A, that will be this L distance twice of it. So 2L distance. Okay, one second. Hello. Right. So the distance traveled is almost 2L. Then how many collisions does it make per second? So which means time taken would be distance traveled per speed. This is the time taken. So number of collision is per time. So per time as in 1 by t, it should be ux by 2L. So we'll be using that. So number of collisions per unit second with the wall would be ux by 2L. This is the change in momentum. So change in momentum per unit time will give us force. So change in momentum delta P by delta T. So this change in momentum we have already calculated. So 2 mux per time is this one. So you will get this as the force. So mux square by L is the force applied by that particle. So the total force that is impacting on that particle on the wall, by that particle on the wall, is mux square by L. Pressure would be force divided by area. So area is L square. So mux square by L cube. So this is what you will get as pressure. And L cube is the volume. So PV is equal to mux square. Now till this point, you should be able to understand easily using the derivation. But from here, I want you to know the terms carefully. Check out. P into V is equal to mux square. What does this ux square means? Which means it is the speed of the particle in x direction. And this is about one particle. Suppose if you have certain n number of particles, then this is what it would be, that every particle will give certain amount of pressure. The total pressure will be sum of all of that. So pressure Pt of x will be m by v, I is equal to 1 to n, uxi as in it would be the sum of u1 square plus u2 square plus u3 square and so on. So sum of all of these speeds multiplied by m by v multiplied by this m by v will give us pressure. Now we can define an important term called what is the mean square speed. Mean square speed ux square will be equal to sum of all the speeds, with square of it divided by total number of particles. So this will n is the total number of particles. So this u square and this entire sum, that is this one. So that can be replaced by n times of this mean square. The minute I have written this bar, it means it is a mean square speed. So u square x, with this bar means it is a mean. So the total pressure will be mn by v into u square bar.
So can you repeat mean square speed?
See, by definition, mean square means u x square in x direction. If there are n number of particles moving, then that would be u1 square plus u2 square plus u3 square and so on up to un square. All of that mean I'm taking, which means by n number of particles we have. Okay, beta.
Got it, sir.
Can I write all of this as sum of 1 to n here, summation 1 to n, and
Yeah,
this n I am multiplying with this. So this summation of all of this will be equal to n times of this.
yeah.
So uh, this entire term I'm replacing with that n times of u square mean.
Okay, got it.
And we know that pressure in gases, whatever the pressure which is applied in this direction will be same as this direction, and in fact in all the directions. So whatever the pressure, that is average pressure which is applied on x direction, should be same in y direction, should be same in z direction as well. Okay. And if you see ux square, if this is the mean in x direction, the same amount of mean should be in the y direction, same amount of mean should be in the z direction. So considering that, because if you have a random particles and you make some average in x direction and you're getting certain value, the same average you will get it in y direction, same average you'll get it in x direction, y direction and z direction. So if you write something like this, imagine a particle is moving, right? A particle is somewhere here and it is moving in 3 dimension, right? Then what all this, if at all I try to find out the mean of those particles, then what I can do, I can write its x component, y component and z component, right? So can I write this u square bar, which means mean for a particle moving in 3 dimension, will be its x component plus y component plus z component. And since all these three are same, I can write it as 3 times of ux square bar. So ux square bar is equal to 1 by 3 times of u square bar. So u here is the speed of a particle in all the directions. So therefore, if I can replace this, you can see u square bar. If I replace that by 1 by 3 times of u square, so then I will get this as 1 by 3 mn u square bar. I guess all of you understood that,
Yes, sir.
right? So what is the mean square speed from here? You can understand that. So mean square speed, considering you have n number of particles, so u square bar will be u1 square plus u2 square plus u3 square and so on up to un square by n. This u1 means there is a particle 1 which has certain speed u. Okay. There is a particle 2 which has certain speed u2. There is particle 3 which has speed u3. So if you take sum of all of that divided by n, you will get a mean square speed. Okay. Now see, total kinetic energy. Total kinetic energy will always be equal to half of m into u1 square plus u2 square plus u3 square, right? Because sum of all these particles, if we take half mu square, we will get total kinetic energy. And just now we got that u square into n will be equal to this. So instead of this, I'm replacing with m into u bar square. Now we know PV is equal to 1 by 3 mn u bar square and kinetic energy is equal to half mn u bar square. So you can equate these two. I mean, in case if you check out the total kinetic energy, we can relate these two and get different, you know, derivations. For example, if you check out total kinetic energy, I can write this as 3 by 2 PV because this half into, mn u square can be replaced here with kinetic energy, 2 times of it. So therefore, total kinetic energy will be 3 by 2 PV. PV I can write it as nRT. So 3 by 2 nRT. So total kinetic energy is equal to 3 by 2 nRT. What important part here is it dependent on both. Here you can see this kinetic energy, total kinetic energy depends on both N as well as T. Total kinetic energy will always be dependent on number of moles as well as the temperature. Now, if you see average kinetic energy, it is the total kinetic energy divided by the number of particles, because if you have some 100 value as the total kinetic energy, if you want to find out per molecule, so you just divide it by the total number of molecules, correct? So if you have n number of molecules, total kinetic energy by n will give you average kinetic energy. This average kinetic energy is of one particle, okay? So that will be 3 by 2 nRT. Number of particles, I can write it as n into Na, because number of moles, we can write it as n by Na. N is the number of particles divided by Na is the Avogadro number of particles. So n can be written as n into Na. So I'm just replacing this n with n into Na. So this nn will get cancelled. I'll get it as 3 by 2 kT. So another very interesting thing is average kinetic energy does not depend upon number of moles. It only depends on temperature. Okay. And here this R by Na which you are getting, we can replace that with a new constant called Boltzmann's constant, R by Na, which is 1 by 3 into 10 raised to the power of minus 23 is what you will get. Okay. So this is a very important note, everyone. I suppose you should remember this. Total kinetic energy depends upon N and T, while average kinetic energy of a particle depends only on temperature. Okay. And now coming to the root mean square, URMS can be represented as the root of, square mean here. So URMS will be equal to root of, this is square, mean square speed, correct? So these are the summation of all the squares divided by n, which gives us the mean. So total kinetic energy is written as half into mn u square, which is equal to 3 by 2 nRT. We just derived this earlier. Now I can write this as 3 by 2 nRT is equal to half into m u square. If you check it out here, this n will get cancelled. And another important thing is this m into n which is there, this m is a mass of single particle, n is the total number of particles. Got it? So using this relation, we can get this. I hope you understand this. M into n can be replaced as m by na into na, which is m into n. Where it is coming from, think this way. Number of particles, I can write it as n by na, okay? And mass into n, this will give us number of particles, right? Sorry. Okay. Molar mass by m. This would give us number of moles. So now you can see that if at all, I can write it as m by m. M is the molar mass. Molar mass is represent. We know that molar mass is represented for 1 mole of it. So if you have m mass of a particle, got it? Then this is for one single particle, got it? So for single particle, whatever be the mass, single particle mass into n. So this give us the total mass, right? So this total mass divided by m, that should give us number of moles. And number of moles, I can write it as n by Na. So this n, if at all I replace by n into Na, right? So I would get that m into n is equal to m into n. Remember, this and this are different. M is the mass of single particle, n is the total number of particles. M is the molar mass, n is the number of moles, right? So this m into n can be replaced by this m into n. So if at all I replace that here, this m into n, I'm writing it as n into m. So this nn will get cancelled. So RMS will be equal to 3 RT by m. And if you take root of it, right, this is what we call it as RMS speed, which we will derive it as 3 RT by m. So what are the takeovers from here? One is the RMS speed. Second thing is how to put total kinetic energy. Okay. Second, this is a very important note. What is the average kinetic energy? And its value is 3 by 2 kT. Okay. Next important takeover from here is PV is equal to 1 by 3 mnc square. So these are some important pointers you should get out from kinetic theory of gases. Not that these derivations are important, but the application of this, all of these terms is very, very important for exams. Okay. URMS can also be written in terms of pressure and density this way, because PV is equal to nRT. I can write it as PM is equal to dRT. So this RT by M can also be replaced by P by D. So URMS can be written as 3 times of P by D. Okay. Now, what are the types of problems we will get? Let's see. And what we usually face the problems. Let us, for instance, if you have a simple question here like this, calculate the pressure exerted in ATM by 10 grams of O2 in 2 liters container, given URMS is 200 meters per second. See, for pressure, all we know that PV is equal to 1 by 3 mn c square. This is what we know. I can write this as c square, or originally how it was, which is u bar square. Now, here, if you check out this m into n, that is the total mass of that gas, which is already given 10 grams of O2. So this mn itself is 10 grams. So which means pressure would be equal to 1 by 3 times of 10, which is in grams. So I have to convert that into kgs. So 10 raised to power of minus 3 into u square. URMS is given. RMS square would give us this mean square. So that would be equal to 200 whole square. That divided by volume. Volume is given 2 liters, but as per the units, we are taking everything in SI system. So 2 into 10 raised to power of minus 3. Okay. So I guess you understood that. So one of the 2 will get cancelled here. So we will have this as 2 by 3 into 10 raised to power of 5. Okay. And if you want that in ATM, I would be dividing this term 10 raised to power of 5 into 1.013 into 10 raised to power of 5. Okay. So it is approximately, right, which is approximately 2 by 3 ATM. So I want all of you to understand the unit conversions carefully. All right. You have to do everything in SI system only. I guess all of you understand that?
Can
Yeah.
you explain again?
Okay. Check beta. We know the equation PV is equal to 1 by 3 mn c square. 10 grams of O2, which means this is the total mass of O2 in the system. Total mass is nothing but this mass of a single molecule multiplied by total number of particles. So m into n is the total mass of the gas given. which is given as 10 grams already. So I have to convert this 10 grams into kgs. So 10 into 10 raised to power of minus 3 multiplied by mean square speed. Mean square is RMS is given as 200. RMS square will give us mean square. So 200 in square of it. Then 1/3 into mn. This is the mn value. This entire thing is mn value divided by volume. Volume is given as 2 liters. So I have to convert that liters into meter cube. You know that 1 liter is equal to 10 raised to power of minus 3 meter cube. So I'll use that fundamental here. So 2 into 10 raised to power of minus 3. So this 10 raised to power of minus 3 will get cancelled. I have 10 raised to power of 4 here into one more 10. So 10 raised to power of 5. This is 2 square. 1, 2 will get cancelled. 2, there is one 3 carried here. So 2 by 3 will be coming. Now all of this what we got is in Newton per meter square or pascals. This is in SI system. And we know that 1 atm is equal to 1.013 into 10 raised to power of 5 pascals. So I have to divide this entire thing by 1.013 into 10 raised to power of 5 so that it will convert into atm. Is that clear, beta?
Yes, sir. Thank you, sir.
Check out the next question. First, I'm doing simple ones so that you can understand the units carefully, okay? Calculate the URMS of N2 gas at an altitude of 20 kilometers where the temperature is 200. Okay. So basically here the importance is only about temperature because you know that URMS is equal to under root of 3 RT by M. Okay. Now while doing it, just check out the units carefully. Everything I have to put it in SI system. So R should be 8.314 into temperature, which is 200, divided by molar mass of N2, which is 28 gram per mole, right? So I have to put it in kgs per mole. So this will become 28 into 10 raised to the power of minus 3. So just notice the units. That's all is important here. Okay? So molar mass should be written in kgs now, not in grams. So when you solve for this, you'll get approximately 422 meters per second. Okay, everything is in SI system. I guess you got this, everyone.
Yes,
See the
sir.
next one. Calculate total kinetic energy of a sample of 10 grams of hydrogen gas at a temperature of 27 degrees centigrade. See, the minute you see the word total kinetic energy, because total kinetic energy depends upon both number of moles as well as temperature. So first calculate number of moles, which is 10 by 2, which is 5 moles. Okay, so we got number of moles as 5. Okay. Right. Next. So we got 5 moles here and temperature is given already 27 means temperature is 300 kelvins. So we just have to substitute that here. So what do we get? So total kinetic energy is equal to 3 by 2 times of 5 into 8.314 into 300. So this is what you will substitute. Okay. So on doing that, approximately you will get this as 18.7 kilojoules. Okay. Because everything is coming in joules. So you take 1000 out, that will become 18.7 kilojoules. Again, check out the unit conversions. Do not put anything like kilomoles, okay? The SI unit of moles itself is moles. It is not kilomoles or something. So you have to just put in moles. Weight you have to convert into kgs, but not with the moles. Everybody got that? See the
Yes,
next
sir.
one. Okay. See the next one.
Just a second, can you show that once again?
Yeah.
Okay. Thank you, sir.
Okay. See the next question. calculate average kinetic energy per molecule, then the pressure exerted, temperature of the gas in the same temperature of gas in the same is the same as that of oxygen gas having mass 64 grams is kept in a container of 22.4 liters having a mean square speed of 400 meters square per second square. Here it is directly given mean square speed. It is not root mean square, means it is u square value, right? So it has been given u2 square, sorry, u square here, that is given as 400 meter square per second square. U, which is mean square speed, u bar square is 3 RT by m, right? Because the root won't be there, which implies temperature would be u square bar into m by 3r. Okay. So the minute you come across this, I would recommend first always calculate temperature, which makes your next step very easy. So if you calculate the temperature, this is given as 400 already. Okay. That multiplied by molar mass. Okay. Now see the molar mass. This is about oxygen. So that would be 32. Now this is in gram per mole. I have to convert that into kgs. So into 10 raised to the power of minus 3 divided by 3 times of 8.314. So again, careful with the units. Got it? So you do this, approximately you will get a temperature of 0.513 kelvins. Okay. Almost close to 0 kelvins. Got it? So this is a temperature which you will get. So once you calculate the temperature in kelvins, rest of the things would be easy. Now you see, we wanted to calculate what is the average kinetic energy per molecule. If you check out average kinetic energy per molecule was found to be 3 by 2 into kT. It does not depend upon number of moles. And the value of K is 1.38 into 10 raised to the power of minus 23. So that would be 3 by 2 times of 1.38 into 10 raised to the power of minus 23 into temperature 0.513. So that comes to be 1.06 into 10 raised to the power of minus 23 joules. So this is what you will get, average kinetic energy. Now, last thing is about pressure. Now pressure we can calculate using this formula, which is PV is equal to 1 by 3 mn c square. Either this, or we can simply use PV is equal to nRT, because the rest of the data is known to us now, because I already calculated temperature. Volume is given here, is kept in a container of 22.4 liters. Got it? So rest all things are given here. So you should be able to calculate using PV is equal to nRT. So nRT by V. This time for calculating the pressure, definitely we need the information of the gas. So this gas is same as oxygen having mass of 64 grams. So now we know the mass of that gas. So therefore number of moles of the gas will be 64 divided by 32. Right. Next, so we know the number of moles here. Temperature we just calculated as 0.513. Volume is given 22.4 liters. Correct? Here, check this. I want answer in ATM. Temperature, pressure, I want in ATM units. Then what should be the R taken? The R we should take it as 0.0821. Right? So depending upon what is our need, accordingly you use the units. So therefore number of moles is 64 by 2, 64 by 32, which is 2 times of 0.0821 into 0.513 divided by volume, which is 22.4 liters. So I guess all of you understood how to use the units. So that would come as 0.003780. Everyone just go through that once again. Understood, everyone?
Yes.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
you guys will try this now. Okay. I'll give you a minute. Just have some water and come back. This is Maxwell's Boltzmann's distribution curve. Got it? First of all, let's see what is the basic assumption. The speed of the molecule of a gas changes continuously as a result of collisions. Therefore, we always talk about average speeds, which means if a particle starting from here make a collision with a speed u1, then again after the collision it changes its speed. After again a collision it changes its speed. One more collision it changes its speed. So the speed of the particles will continuously keep changing every second. I mean the every time it makes a collision. So it is always be important to talk the average speed rather than the individual speed. Second, the observed properties like pressure, average kinetic energy do not change with time. Okay. So it is expected that it would be possible if number of particles between any two definite range must remain constant even though the speed of the individual particle may change, which means this average which we are drawing out of it, like we have drawn URMS, total average kinetic energy, only kinetic energy average, got it? Pressure, they do not change as long as you keep temperature constant, as well as uh, you know no matter how much you keep it for long time. So it is not going to change with respect to time. So we will be discussing about these terms more than individual pressure, I mean individual speed and so on. Okay, so these are the important assumptions while talking about Maxwell's Boltzmann's theory. Now coming to this, suppose, okay, before getting into that, you know how your distribution of marks would be usually. Okay, suppose in your class there are 100 students. Okay? So out of those 100 students, not everybody would get similar marks. One might get 90, one might get even 10, one might get, some 3 4 students might get 20, some students might get 50. So this way, if you check out between two certain marks, for example 55 to 60 marks, between this range of marks, let us assume there are a total of 20 students. These are around 20 students. Like that, if you distribute the entire division of marks, correct? That's how we do usually give the grades also. Like 0 to 5 marks, 5 to 10, 10 to 15, 15 to 20. Like that, I've made up to 100 from 5. Okay, 0 to 5, 5 to 10, and so on. I made this into different categories, and every time I'm finding how many number of students are there. 0 to 5 there is only one student, got it? And 5 to 10 there are 20 students, like that. So 10 then 10 to 15 there are 30 students, like that. If at all I keep plotting between the ranges of marks versus the number of people present in that range, this is called distribution of your class. Correct? This is called the average distribution of the class. I guess all of you understood what it is. Okay. So the same thing, if at all I make a distribution of speeds versus the number of particles, various different speeds between 5 meters per second to 10 meters per second. How many gas particles do we have? 100 meters per second to 200 meters per second. How many gas particles do we have? Like that, if at all I put the distribution with respect to number of particles, that is called the distribution of gas. Most of the time, a random sample distribution, random sample as in having different, like for example in your class, if the marks range are ranging right from 0 marks up to even 100 marks, all almost all different values every student has got. So that is called a random data. Whenever we have a random data and we make a distribution out of random data, we usually get something like a bell curve. This is called a bell curve. A very familiar curve you'll be using a lot in maths, going ahead also. In engineering, we'll be again using this a lot of times. Okay, especially who are doing statistics, they must understand better. So point is, here you will get some distribution curve like this. Now for this, if at all I represent that in a mathematical format, I will get a formula. That formula is this, right? What does this mean? If at all I take particles between u and u plus du, okay, speed is u and u plus du. Between this range of speed, how many number of particles do we have? Dn number of particles. So this is the generalized formula for distribution pattern. Everybody got this? This is called Maxwell's Boltzmann's distribution curve. So check out, dn is equal to 4 pi n. N is the total number of particles. M molar mass divided by 2 pi RT to the power of 3 by 2 exponential of minus mu square by 2 RT into u square into du. Okay. So basically this expression is telling us the total number of particles having the speed range of u and u plus du. I hope all of you understood that. Yeah.
Sir,
Haan, beta.
in the formula, it's u square d u or it's n.
U square
U square d, and what's the last letter? It's u
du.
or n.
This is u square du.
Okay, sir. Okay, sir.
Okay. Okay, guys. Right. So I guess all of you understood that. Now, this term can also be written, in various different formats. For example, the same equation, if you observe, there are two functions present in it. One is exponentially decreasing function. The other one is u square. These are all constants. What does this u square represent? A parabolic function. Exponentially decreasing function is also present with it. So I'm getting two functions here, which I'll write it this way. 1 by n dn by du is equal to 4 pi m by 2 pi rt to the power of 3 by 2 u square into exponential of minus m u square by 2 rt, right? This is what you have. Now, what I'm doing, observe carefully, this entire term which is there, this entire term, I'm taking it as a constant value and I'm assigning this as some a. And here also this entire term m by 2 rt, I'm assuming this as b. And this entire term here on the left hand side here, this I'll take it as some y. So I can take this as y is equal to 4 pi a u square into e raised to power of minus b, sorry, this I'll take it as x. So 4 pi a x square minus b x square minus b x square. Can I write this? Everybody understood that? So y is equal to some constant into x square multiplied by e raised to power of some constant into x square. So one is the exponentially decreasing function, the other one being an parabolic function. Okay, guys. Now, if you observe this a value and b value, both of them are dependent on m by t ratio. So a and b both depends on m by t value. Okay, what is this dn by n? Dn was the particles, present between u and u plus du. Dn by n means fraction of particles present. So let me write down that. So dn by n represents fraction of particles present between u and u plus du speed. Okay, suppose If at all you see for molar mass m and constant temperature T, as we can write this graph as 4 pi ax square into e raised to power of minus bx square. These two functions, this part is a parabolic part, this part is an exponentially decreasing part. You know that parabolic part will go like this and exponential form will go like this. Exponentially decreasing function will go like this. Okay. So what you will observe here at low speeds, okay, generally at low speeds, parabolic function is always more dominant. Okay, so this value almost reaches to 1 because at low speeds, which means this x value is very small, this will be e raised to power of minus some small value, which means it is tending to 1. So ax square will be more dominant function at lower speeds. But higher speeds, this value becomes so, the upper value becomes so big in negative that it will become almost 0. So this will try to drag down to 0. Got it? That's why overall function will have first a parabolic part and then an exponent part which is dragging towards 0. So this part is that parabolic part, this part is that exponent part, and always gives a maxima at some point. Okay. So see what I'm plotting on y-axis and what I'm plotting on x-axis. Y-axis it is dn by n into du. This is the y which I have used here, that versus u. If I use this, correct? Then what about anything under this area? Check out. Area under this curve would be what? Suppose if this is a du amount, small change, that multiplied by y, what should I get it? I should get area under this curve. So what am I getting here now? So dn by n du multiplied by du will get us dn by n, which is fraction of particles present, in total number of particles, which is dn by n. Like this small fractions, if I add everything, what should I get? I should get area under the curve, complete area under the curve. And how much that will be? That should be equal to 1. Let me show you that. Suppose if you check out area of this rectangle, area of this particular rectangle, that will be dn by n. We just proved that. Suppose if it is about one particular range here, okay, so like this, I'm taking small ranges, this one, and I'll take this one, and I'll take here. Like this, if I keep on adding all small dus, I should get the overall number of particles present per total number of particles. That's what we have done here. So suppose if at all I take small range of du from u1 to u1 plus du, then let's say the number of fraction of particles is dn1 by n. Similarly, if I take range from u2 plus du, then fraction of particles I took it as dn2 by n. What will be the area under this curve? Area under this curve will be dn1 by n, this fraction plus further fractions. If I add all these fractions, what should I get? Above all the fractions, if you combine, it should come out as n by n. So it should be 1. So that's why the area under the curve, when you check out, it should come as 1. The same summation, if I write in terms of integration, what would I get? 0 to infinity. If I add all those small, fragmentations by n, it should come as 1. I guess all of you understood this.
Yes, sir.
Yes, sir.
Okay. Now see this. Using this concept, we should be able to calculate other types of speeds, which includes what is the most probable speed, what is the average speed, and so on. Most probable speed should be equal to root of 2 RT. So how do we do this? You can simply use this equation. Y is equal to ax square into exponential of minus bx square. We know that most probable as in the speed where it is maximum. maximum number of fragmentations you are getting, or maximum number of particles you are getting. So this is that u most probable. So at this point, the first differentiation will be 0. So at maxima, derivative will be 0. So you differentiate this. On differentiating that, we will get something like this. So dy by dx is equal to exponential of minus bx square into 2ax plus ax square exponential of minus bx square into minus 2bx is equal to 0. So if I take this common, exponent minus bx square into 2ax, if at all I take common, I'll get this as minus bx square plus 1 equal to 0. So x can be equal to 1 by root b, which is equal to under root of 2RT by m. Okay. So that's how we would get this as u most probable will be equal to under root of 2RT by m. One thing you can notice is that most probable is in fact less than u RMS, which is root 3RT by m. Okay. Now, what are the type of questions? This year also, year 2020, there was one very good question in here in advanced, which is based upon these fractions. So you got to understand how these fractions work. Check out this question now. Find the fraction of particles whose speed lies between u most probable to u most probable plus du. Okay. This year it was made even more complex with adding a fraction here. I'll show you one of the questions like that. Check out what it is. Dn by n, what we know by the formula is 4 pi m by 2 pi rt raised to power of 3 by 2. Okay. Then exponent of minus m u square by 2 rt into u square into du. This is how it was. Now instead of this u, what he's saying, what if it is most probable speed, with small gap of du. So in this du, what are the fraction of particles present? So what I will do, I will replace this u square with its value. Okay. So what is the value of that? So u square is 2RT by m. Here also it is 2RT by m. Okay. So you can see in the exponent, everything is getting cancelled. Mm will get cancelled here. 2RT and 2RT will get cancelled here. So what is left out here? You will get this as 4 pi into m by 2 pi RT whole raised to power of 3 by 2 exponent minus 1. So what everything is getting cancelled out there. Multiplied by 2RT by m into du. Okay. Now this RT by m, I can bring this inside this as well, because this is m raised to power of minus 1. So m raised to power of 3 by 2 minus 1. So that will give m raised to power of half. And same 2RT also I can put it down here. So therefore I will get this as only pi, I have to remove it out. So 4 pi by pi of 3 by 2. If I bring that, rest will be m by 2RT whole raised to power of half into e raised to power of minus 1. So this brings at 4 by root pi, because this pi, if at all I take it down, I will get this as root pi into root of m by 2RT, root of m by 2RT into 1 by e. So this is what you will get. Guess all of you understood that? Right. Same thing, you should be able to calculate the fraction of particles for u RMS speed in the same formula. Instead of m by 2RT by m, this time you will put 3RT by m. Okay. So when you put 3RT by m, I'm directly writing the final calculation which we will get. Dn by n, which you will get, will be equal to something like 4 pi by 2 pi whole raised to power of 3 by 2 into m by RT whole raised to power of half, okay, into 3 times of e raised to power of minus 3 by 2. This is what you will get. So I think you should be able to figure it out. Just introduce this instead of 2RT by m and 2RT by m here, write down 3RT by m. You should be able to get it. Okay. So I'll show you how this year's question was. Okay, and usually how the questions, tricky questions will be asked from here. Another thing, there was one year in 2016, it was based upon the definition of average speed. Please understand what is an average speed. Now imagine if at all I have to make an average of all your marks in the school. Okay, in your class there are 100 students. Now I'm trying to average it. There may be students who got a similar score as well, right? You know, some students might have got 10, some student might have got 20. So what I'm doing, see, 5 students got 10 marks, 3 students got 20 marks, 15 students got 40 marks, plus and so on. Like this, what I'm doing, I'm taking, these are clusters of marks. So this 5 students, 3 students, 15 students, okay, multiplied by these respective marks, got it, all divided by total number of students, which is 5 plus 3 plus 15 plus so on, correct? This is averaging. I hope all of you understood that. This is a simple mean average. So I'm writing the same thing for U average here. U average is equal to dn1 into u1, fraction of particles, sorry, number of particles, you know, small number of particles having the speed of u1 plus dn2 u2 plus dn3 u3 and so on, divided by dn1 plus dn2 plus dn3 plus and so on. This should be the average speed. If I write as a summation of this, can I write this as summation of I is equal to 1 to some p. P as the total number of parts like this. That is dni into ui divided by summation of I is equal to 1 to p dni. What happens if you add all the number of students? We should get the total number of students always. So therefore, below I will get it as n only. Above this summation, if at all I put in terms of integration, so this dn will become even smaller. So this dn becomes smaller and smaller. So which I can write this as integral of 0 to infinity. Imagine there are so many parts of it. Will become u into dn. How many of you understood this? Anyone has a problem? Please let me know. This is the actual definition of u average. Chaitanya, you understood that better? What is u average?
Yes, sir.
Others?
Sir, I have something to ask.
हाँ बेटा.
Sir, could you discuss pace question paper of the Sunday if time permits?
Yeah, after the class, okay? Chaitanya, after I finish the class, I'll give another half an hour so we can discuss that, okay?
Okay, sir.
Everybody, you got this?
Yeah, sir.
Okay.
Yes, sir.
So that would be equal to, now what I have to do is 0 to infinity here, which is 4 pi n, the root of m by 2 pi rt raised to 3 by 2 exponent of minus m u square into u cube into du divided by n. So if you do that integration, you don't have to do that, you know how it is. You just have to worry about the result. So it will come out to be 8 RT by pi m. So this will be the U average. Everybody understood that? How to get it? Now, just like how we have done it for U, R, M, U, M, most probable speed and RMS speed. Do the same thing for average also. This you will finish it. Okay, I'm leaving it as a blank. You better try that. Put that entire terms here properly. Instead of 2 RT by M, this time we'll put 8 RT by pi M, and accordingly see how many fraction of particles you will get. Okay. Now this year's question was based on this. And this is another very important type which is normally
So,
asked. Haan, beta.
your voice is cracking a bit. Can you repeat what you said?
Okay. All I said is the way we have done the questions for fraction between U MPS and U MPS plus DU, do the same thing right now for average and average plus DU. Okay.
Okay.
Yeah. This I'm leaving it as a blank. You better
So just replace that by 2RT,
8 RT by pi M.
8RT per pi. Okay.
Now, here this year also there was a question based on this fraction. Instead of C, I could have used this as U most probable plus, right? Sorry, U most probable to Q most probable plus DU. This is what we have solved. What if instead of giving DU, he has given some fraction multiplied by URM, U most probable. Got it? So this in fact was du what you were discussing. Okay. So I will directly fetch the result from above, from here, and then we will see what we would get. This into du. There was a du missing here. Okay. So I will directly take it from here. So after solving everything, let us imagine we got this. Sorry, not here. This next question. So imagine we got till this point. Okay. Now instead of this du, I have to replace that with what? F times of U MPS. Everybody got this point now? This F is a fraction which is present between 0 to 1. Okay. So which means I will write this as 4 by root pi into M by 2 RT multiplied by 1 by E into F into URMS. URMS is under root of 2 RT by M. Okay, this is 2 RT by M here. Okay. Now if you observe this 2 RT by M and this M by 2 RT, everything will get cancelled here. So what do we left out? We'll be left out with only 4 by root pi into F by E is what you left out with. You guys understood that?
Yeah, sir.
Right. So while doing the fractions given, so one best part you will get this is dn by n will be directly related to the number of fractions that are being given. Okay. So most of the time you will see all of these terms m by rt, this will get cancelled with the other term which you have used. Okay. So rest all things will get cancelled and dn by n will be only proportional to f. Yeah, you guys understood that? Right. So this was one of the match the columns which was given, in JE before. So what it was, see this and work carefully. You have to work out. I'll just give you the hint. You have to find out a ratio of dn by n lies between most probable to most probable plus du. This is the first one with RMS to RMS plus du. So first two questions which we have worked out, उन दोनों का ratio लेना है. These two, this one and this one, ये दोनों का ratio. This was the first part of the match the column. Second, ratio of dn by n of oxygen and sulfur dioxide gas lies between URMS to URMS plus du. So URMS once apply for oxygen, which means molar mass, write it as 32. Second time write molar mass as 64. Then check out the ratio between those two. कितना आएगा? Suppose all of you understood that. Next, dn by n of oxygen and sulfur dioxide with most probable this time. Same question with most probable. Last question, dn by n for oxygen and sulfur dioxide gas between U average plus 0.5 U average.
So,
Understood? Yeah? Yes.
could you repeat what you said for the third one?
Third one.
It was again thoda.
Okay. Second one and third one are quite similar. यहाँ पर RMS यूज करना है, यहाँ पर मोस्ट प्रोबेबल यूज करना है. ऊपर जो भी हमने डिराइव किया है वो आप एक बार उसमें मोलार मास में ऑक्सीजन का मोलार मास रखोगे, एक बार SO2 का रखोगे और दोनों का रेशियो लोगे.
Okay, got it.
Last one, dn by n for oxygen and sulfur dioxide. Between these fractions, one very interesting point what we have noted down that dn by n when you take out, तो वो सब कुछ कैंसिल होके सिर्फ इसी टर्म में बच जाता है ना, फ्रैक्शन के टर्म में बच जाता है. सो इट विल ओनली बी डिपेंडेंट ऑन फ्रैक्शन. सो इफ यू आर आस्किंग फॉर द सेम फ्रैक्शन, दोनों के लिए सेम ही रहेगा, बाकी सब कैंसिल हो जाएगा. इज दिस क्लियर? सो इस इनफैक्ट इसका आंसर 1 आना चाहिए रेशियो निकालोगे तो. I guess all of you got this. I'm leaving some space again here. You have to properly write and calculate. Okay. ऐसे typical ये वाला एकदम typical type of question है. So this is the area you should focus more and try this. I guess all of you will do that. Yeah. Match the correct answers out of it. Okay. Right. Now coming to the application of the speeds. U RMS, U most probable and average. Where do we use this? First of all, if you see the value wise, if you check it out, we know that U RMS is the highest, which is √3 RT by M. Then comes U average. Then comes U MP. So U MP is that point where you have maximum number of particles. So you can see fraction of particles most probable will have maximum as compared to that of, oh, I made a mistake here, average, compared to that of average and compared to that of root mean square. Okay. And if you see the values, you know that U RMS is more, and if I take the ratio, that would come as √2, 8 by 4 and √3. Okay, so that would be the 1:1.1.112 and 1.225. This is what you will get it as the ratio. Okay, the ratio as well as this part, you know, directly as mains questions have been asked a lot of times, so you better remember this. Now coming to the most probable or any speeds, if you observe one thing, when I write dn by n, it is proportional to root of m by t in both u square function, also, as well as exponential of under root of m by t. So you will always get this as m by t for sure. In the overall equation, when we write the Boltzmann's curve, we always get it as root of m by t. I told you while writing a and b also that y is equal to 4 pi a x square exponent of minus b x square. I told you there also that this a and b both will depend on m by t. So for example, if you have m by 2 value changed, okay, so imagine this. These two are at two different temperatures where T2 is greater than T1. So T2 is greater than T1 for the same gas. So which value will be more here? M by T, if you check out M by T1 and M by T2, which value will be more? This will be more because T2 is greater than T1. In that case, if M by T value is more compared to that of M by T2, which means this should be more dominant in the parabola and less dominant in exponent form, because in the parabolic function it is helping it as it increases. Check out 4 pi m by 2 pi rt whole raised to power of 3 by 2 u square. This is the parabolic part. And e raised to power of minus m by 2 rt u square. This is the parabolic part. Sorry, this is the exponent part. So in the parabolic part, m by t ratio अगर ये बढ़ जाएगा तो ये पूरा टर्म का वैल्यू बढ़ जाएगा. Aradhya, connected back? Yeah. Okay. Check this. What I'm saying, for A and B, if you check out, m by t ratio, if it increases, then this function will increase. M by t, if this increases, this function will decrease. So check out, that is what we are saying. If m by t value is more, the parabolic part is increasing, but exponent part is decreasing. Okay, everybody understood that? Originally, if you consider t2 by t1, I mean t2 and t1, m by t1, m by t2 दोनों को compare करो. M by t1 is greater than m by t2, which means this is and m by t, if it is more, then parabolic function will dominate, exponent function will be less. Remember only one part of it, that should be helpful. Is this clear, everyone? Now check this. For different gases, if molar masses are different at same temperature, then m1 by m2, m1 by t, m2 by t, if you consider, and if m2 is greater than m1, right, then here this m2 by m1 wala part dominant hoga parabolic pe, and then less hoga exponent pe. So this should be m2 wala graph and this should be m1 wala graph. I guess this point is clear. So these are the direct equations asked in JEE Advanced. Got it? Like what happens in case if you have parabolic function, exponent function, whether it will increase or decrease. Guys can see now?
Yes, sir.
See, at low pressures, at low speeds, parabolic function will dominate. So if temperature is increased, this is for the same gas, molar mass same hai. If only T increases, number of particles will decrease for parabolic part. Exponent part, number of particles will increase. Got it? This is at low, as the temperature increases. Okay. You can see that as the temperature is increasing, ये कर्व नीचे की तरफ जा रहा है ना, ऐसे नीचे चला जा रहा है. Same way, same temperature, different gases. मोलर मास इंक्रीज हुआ तो dn by n इंक्रीज होगा पैराबोलिक पार्ट के लिए, और dn by n डिक्रीज होगा एक्सपोनेंट पार्ट के लिए. Different temperature, different gas, then just check out m by t ratio. If m by t ratio is more, parabolic part dominates. M by t ratio is more, exponent part will be less. Okay, so this was asked in 2003. Got it? To plot the graph for these 4 cases. Okay, so SO2, you know, at around 300 kelvins, SO2 at 150 kelvins, SO2 300, O2 at 300. Check out for all of these cases, how would I plot it? First case. Okay, I will first write those two and see which one is more matching. Best part is check out m by t ratio. M here is 64 divided by 300. Here it is 64 divided by 150. So obviously this is more dominant value, right, everyone? So since this is more dominant value, तो ये वाला curve B का होना चाहिए, ये वाला curve A का होना चाहिए. So this would be B and this would be A. I suppose all of you understood that. See the second curve. Now this time temperature is same, molar masses are different, and this molar mass would be more. So you can easily make out, suppose if you have these two curves, then this should be for SO2 and this should be for O2. Yes, that is clear. See the third one. If you have SO2 400, so which means 64 by 400, and here it is 32 by 200. The ratio is coming out as same. This is also 32 by 200 only. This is also 32 by 200, which means both graphs are one and the same. So A and B, both of them are same. Fourth one, SO2 at 500, O2 at 300. So this is 64 by 500 and this is 32 by 300. So you can see this value is dominant because this is 32 by 250. So which means if I put these two graphs, this would be for A, this would be for B. So everyone please look over and let me know if you have any doubt. Finished? Got that, everyone? No? Okay. Any doubt so far?
No, sir.
So,
Okay, I want a little bit of more patience now because this is slightly going to be difficult. I'm not sure if collision theory is done for you. Bimolecular collisions are done. Those were taught. Anyone? Chaitanya?
Yes, sir.
Bimolecular collisions were taught to you?
Yes, sir. So gaseous state खत्म हो गया है.
Okay, ठीक. मतलब ये पार्ट आपको समझना चाहिए फिर. Okay, bimolecular collisions आता है आपको?
No, sir. I actually missed one lecture.
Okay, others? यश, bimolecular collisions पहले पढ़ा है? मतलब पहले सुना है या?
not really, sir. Not properly.
Arjun, what about you?
Yes, I got it. I understood.
No, not earlier part. Have you heard about this bimolecular collisions? Have you done bimolecular collisions before?
No, sir, I haven't done them.
Okay, so I'm considering most of you haven't done about bimolecular collisions. Okay, so there is this one part, right? So which is useful for JEE Advanced, where you would get questions like mean free path, collision number, collision frequency, how to relate that with pressure and temperature. Okay, let me repeat that: mean free path, collision number, collision frequency, and how to relate that with pressure and temperature. This is one area in JEE Advanced, so we will focus on that. Now check. Our entire objective is to find out how many collisions are happening per second in a system. That is the whole objective here first. The first assumption is we are only considering bimolecular collisions. Matlab at a time, one molecule is making only one collision. Okay, so it means you cannot expect that 2-3 molecules are colliding together. Okay, I'm assuming this is not happening. So at an instance, one molecule will collide with the other molecule. That's all. Now consider a container having one type of molecule, which means their diameter is same. This is the first thing you got to understand. Sabka size same hai. Next, assume all the particles or molecules in the container are stationary except one reference molecule which is moving with speed u. So everybody check out, all of these particles are stationary. Imagine this is the first situation which you are. Then we'll slowly develop from this theory. Okay. imagine this particle is the only particle which is moving. This is the reference particle. Now tell me, if that particle keeps moving, in 1 second, what is the distance it will cover? Let's say this started with this point A and reached towards point B. How much distance will it cover? Let's say this distance is L. L divided by 1 second, that should be the speed. So the length will be same as the speed because time is 1 second. So what is the distance that it will cover? It is the magnitude of that speed with which it is going. So this distance would be how much? U bar. I guess you understood, everyone. Yeah. And like I said, the diameter from now onwards, I'll represent it as this sigma. Okay. So sigma is the diameter of that particle. Now I want you to assume a cylinder, around this, just above this, such that the center of this cylinder will coincide with the center of the particle at position A and particle at position B. So I hope you guys can imagine the cylinder, everyone, right? And this cylinder must have a radius which is same as the diameter of the molecule. So this means this value should be, the radius of this cylinder should be same as the diameter of this particle. Okay. And the distance between A to B, which is the distance which has traveled by this particle in 1 second. So अभी तक जो भी हम लोग कर रहे हैं, per second, how much distance that has been covered, which is U bar. And I'm just imagining a cylinder around it. So far clear? Now, imagine every molecule whose center lies in the cylinder will definitely collide with this particle or no? If this particle, right? So you can see this reference particle. If this reference particle, if it is present inside the cylinder, then there is a chance that both of them will touch with each other. If the center is away from the cylinder like this, will this particle will touch this? No, right? Everybody understood that point, right? So if the cylinder center lies, right, then with reference to the molecule, a reference molecule, then definitely there will be a collision. But if this particle is not, whose center is not in the cylinder or on the cylinder, then there won't be any collision of this particle during its motion. I'm just showing the motion of that particle, okay? From this point to this point, this is the motion by which this particle is moving. And it will touch all the other particles as long as their center is falling in the cylinder. Everybody understood that? Okay.
Yes.
Okay. Collision diameter, okay. The diameter as in at the point of collision, the diameter which it makes, this one, the distance, which is same as the diameter of the particle, right? So that's what we call it as collision diameter. The collision diameter is sigma only. What will be the collision cross-sectional area? Okay. Next question is about collisions cross-sectional area. What do you mean by collisions cross-sectional area? Which means the pi sigma square, because you can see when these 2 points collide with each other, what is the area that it covers? What is the area that it covers? So pi sigma square. Now what is the volume of the cylinder, guys? Because this is the area that it is covering, correct? Multiplied by this distance. What will you get? We'll get the volume of the cylinder. So can I write volume of the cylinder as pi sigma square into L, distance. This distance is how much? U bar only, because per second this particle has moved from this distance A to B. So this length of the cylinder is same as U bar. Everybody got that? Now, if number of molecules present in the unit volume Unit volume means N by V, number of particles per unit per total volume. This is unit volume, is N star, and number of particles present in the cylinder will be how much? Okay. So whatever the volume that cylinder is covering, which is pi sigma square U bar, this is the volume it is covering, multiplied by number of unit volume, number of particles per unit volume. I guess all of you understood this. This is the total number of particles present in the cylinder.
Okay, sir.
Right. This I can write it as pi sigma square U bar and N star. So therefore, number of collisions made by the reference particle in 1 second, how much it will be? See, whatever the particles which are present in that cylinder, the reference particle will hit with all these particles. No? So the reference particle will definitely make a hit with all these particles. Right, just a minute, Yash. Okay. So pi sigma square U bar into N star. Now, number of collisions made by this reference particle will be same as this one. Because जितने particles रहेंगे उन सब से touch करेगा. These are the number of particles which are present. उतने number of collisions होंगे. And this is what I'll term it as collision number. So collision number Z1 represents the number of bimolecular collisions done by one particle in unit time. Okay, so you can see that pi sigma square U bar N star. These are the number of collisions done by one particle in unit time. And that is a definition as well. It is the number of bimolecular collisions by one particle in unit time. Yes, all of you understood that? Just let me finish this part, then I'll give a break, okay? Now check. Suppose here the assumption was, okay, in the first case the assumption was सिर्फ ये particle घूम रहा है, बाकी सब stagnant है, बाकी सब stationary है. What if all particles are moving? If all particles are moving, imagine this collision किस तरह के हो सकते हैं? This is a reference particle. This is the general gas particle. If both of them will collide with each other, the angle of collision could be 180 degrees. ऐसा भी हो सकता है कि if the speed of the reference particle is more और ये पीछे से hit कर रहा है, तो angle of collision will be 0. ऐसा भी हो सकता है ये ऐसे hit कर रहा है, ये इधर जा रहा था, दोनों के बीच में angle theta होगा, which is an acute angle. ऐसा भी हो सकता है ये particle इधर जा रहा है, ये ऐसे hit कर रहा है, obtuse angle हो सकता है. So can I say that if you consider all the possible collisions और उन सब के angles का average लोगे तो वो 90 degrees आना चाहिए, because it is ranging from 0 to 180 degrees. So all the angle will vary between 0 to 180 degrees. So the average angle of collision should be 90 degrees. So यहाँ से imagine as if this U is coming from this end और ये another gas particle which is coming from this end. तो दोनों का resultant उनका average speed होगा. So U bar and U bar इनका average speed ये होगा, which is U resultant. So that would be U resultant would be equal to under root of U square plus U square, which is equal to root 2 U bar. Is all of you clear with that? Okay. So now therefore, now the number of bimolecular collisions in the cylinder with respect to a molecule, considering now these particles are moving inside, earlier we thought that these red particles were not moving. Now imagine if they were also moving, the speed of this, the average speed of these particles changed. And that's what we will write here, pi sigma square, and U bar, I will write it as root 2 U average, because now that speed has changed to average speed into N star. Okay. Now, therefore, this is called the collision number when all the particles are moving. Okay. And this is the most important formula here. What is the collision number of a particle? So every gas particle will have these many collisions per unit second. Everybody understood that? किसी को डाउट है प्लीज अभी पूछेंगे. Okay, so Z1 is proportional to U average, right? From here you can see that. Consider volume is constant, so N by V will be a constant value. Then Z1 is dependent on only on one factor here, that is U average. So Z1 is proportional to root T by M. Okay. Suppose if volume is not constant, if volume is not constant, I can use PV is equal to nRT also. I can write PV is equal to nRT as N by V is equal to P by RT. N by V is equal to P by RT, or this number of moles I can write it as, you know, total number of particles divided by Na into N is equal to P by RT, which implies into V. This implies I can write it as N by V is equal to P into Na by RT. This N by V is nothing but N star. This is N star. Just substitute, instead of N star, substitute this value here. So what would I get? So Z1 will be equal to root 2 pi sigma square U average into PNA by RT. PNA by RT. U average, we already calculated that as 8 RT by pi M. So if I substitute that here, so Z1 will be root 2 pi sigma square under root of 8 RT by pi M multiplied by P into Na by RT, which implies Z1 is proportional to, ध्यान से देखना, P by root T. ये क्वेश्चन आ चुका है जेई में. How number of particles, number of collisions are dependent on pressure and temperature. Got it? एक बार ये प्रेशर किसी गैस के लिए दिया था, हीलियम गैस के लिए, एक बार ऑक्सीजन गैस के लिए, फिर दोनों को कंपेयर करना था. Not that you would be directly asked about this formula to substitute and calculate number of collisions. They would be asking you this way. So I guess all of you understood this. Any problem here?
No, sir.
So I understood it, but what is Z?
This Z1 means number of collisions made by a particle per unit time.
Okay.
Okay, by one particle. Okay, one Z1 represents that one particle. Okay, beta.
Okay. Sir.
Z11. Now check out Z11. Z11 means this is called collision frequency. It is nothing but this is the total number of bimolecular collisions happening in unit time in unit volume. It is not with respect to one particle, with all the particles now. सारे particles कितने collisions कर रहे हैं per unit time, per unit volume. That is represented as collision frequency. Okay. Now to understand that, I want you to remember this. Like suppose if there are 4 particles and each particle is making collision. So one will make a collision with 2, 3, 4. These are the possible collisions. 2 can make with 1, 2, 3. 3 can make this way, 4 can make this way. But can you notice that 1, 2 collision and 2, 1 collision is same? 1 जाके 2 से collide करे, 2 जाके 1 से collide करे. That is the same number of collision. वो collisions तो replicate हो रहा है. So if you count the total number of collisions here, there are total 12 collisions here. But 12 में से 6 तो common ही है. So which means if you have n number of collisions, then n by 2 are the actual collisions. बाकी सब repetitive है. I think ये point clear है सबको. Okay. So therefore, if there are total 12 possible combinations, 1, 2 and 2, 1 being same, the number of collisions are actually half the possible number of collisions, right? So can I write that total number of bimolecular collisions? See, each molecule is giving how many collisions, beta? Z1. And like that, how many number of particles are there? N number of particles. Can I say these are the total number of collisions? And इसमें total possible collisions में से सिर्फ half of them are the actual collisions. So if I divide that by 2, that is what I will get it as total number of bimolecular collisions. Correct? Acha, but this is not Z11. This I have wrote only for unit time. Okay. But by definition, it is unit time per unit volume also. Okay. So therefore, now if I write the Z11, what would be the formula here now? So total number of bimolecular collisions by all the particles in unit time and in unit volume, which is collision frequency, can be represented as Z11 is equal to half of root 2 pi sigma square into U average into N by V was originally already there. Okay, that multiplied by N. ये पूरा part Z1 है. This is all Z1 multiplied by N and per unit volume again divided by volume. So which means this would come as 1 by root 2 pi sigma square U average into N by V whole square. So this is the bimolecular collision. This is the frequency or collision frequency of bimolecular collisions. I guess you understood this point, everyone. So therefore, if volume is constant here, this part will become constant and Z11 will be dependent on U average only. So Z11 will be directly related to U average and U average is directly related to T by M. Okay. But if volume is not constant, this will be proportional to U average also, and it will be proportional to 1 by V square also, because now volume will be present here, N by V square. So 1 by V square would be present as well. So V square as in this, we would have P into NA by RT. Okay. So therefore, Z would be proportional to P square by T raised to power of 3 by 2 into root M. This is what you will get after substituting this. V के बदले में आप ये लिख सकते हो ना, nRT by P. You can write this as nRT by P. So if you substitute that here, you will be able to get this. जे में अभी तक ये वाला पार्ट नहीं पूछा है, बट जो पहले हमने डिस्कस किया Z1, that was asked. So I guess you should be able to remember these 2 points. What is Z1? What is Z1? Let me repeat that. Z1 is the number of collisions made by a particle in unit time. Total particles of total volume, okay? So, one particle कितने collisions कर रहा है unit time में? Z11 is the total number of collisions made by all the particles in unit time in unit volume. That is Z11. Right? Now, see, this is being asked a lot of times. What is mean free path? Okay. Mean free path is the average distance that is traveled by particle between two collisions. Suppose from this point A, B, C, D, these are all the path which has been followed by a particle during collisions. From here, this particle is colliding at point B and moving towards C, and then here it is making a collision moving towards D. Every time a collision happens, a particle is covering a certain distance. Let us that distance be D1, D2, D3 and so on. So the average of all distance by the total number of collisions, n is the total number of collisions, that will give us lambda. Okay, everybody understood that? So this is by definition, lambda is the average distance covered by n. Okay. अच्छा, average distance per unit time कितना distance cover होता है? Average distance per unit time. We know that that will be same as U average, because per unit time मतलब it would simply be U average, right? That divided by total number of collisions per unit time. Total number of collisions by one particle is Z1. So this was directly asked in JEE. as a formula U average by Z1. Remember this. Mean free path can be written this way. Okay. And we know the value of Z1 already. So U average divided by root 2, okay, pi sigma square U average into n star. So U average cancel ho jayega. So I will be left out with 1 by root 2 pi sigma square and n star. N star is nothing but n by v. N by v, I can replace that with p by pna by rt. So if I write this as pna by rt here, lambda would be proportional to, because u average पे तो dependent नहीं है, it is only dependent on this n star, and n star is down here, so pressure will be down, temperature will be up here. So therefore it will be proportional to temperature by pressure. Very, very important. So if you have to compare mean free paths, you can see how it is related with temperature and pressure. You can be asked like, at constant pressure, if the temperature is increased, what would happen to the mean free path? Mean free path will also increase. At constant temperature, if pressure is increased, the mean free path will decrease. Points clear, everyone? So 3 important terms what we learned, I'll just repeat: Z1, Z11 and lambda. So ये तीनों आप अच्छे से revise करोगे. This would be helpful for problems. So we'll take a small break and I'll come back in 5 minutes. Everyone?
Okay, so thank you.
Yeah.
Okay.
Check this. Hydrogen bonding is definitely a special case out of all of them, which will have very, very high interaction between the particles. All right. This minimum information, I think all of you must have. Right? We could discuss a lot of things, but I don't think is more than this is required. Repulsive forces. See, when particles are very close, then only we will have the repulsive forces. Okay. So when the repulsion happens, the potential energy will be proportional to r raised to power of 12. Okay, this will be the short range forces, which means when the particles are so close, then only we will see the potential energy will start acting in the reverse manner. Coming to the real distinction of real gases and ideal gases. See, ideal gases were assumed to have no interactions and volume of their particles is not considered in front of volume of the container. While real gases, we definitely consider volume of the real gases, and these are not neglected, as well as interactive forces between the particles are not ignored. So that's a major difference between a real gas and an ideal gas. Then you may have come across Van der Waals real gas equation. And this is the equation, got it? Where we have pressure, volume, number of moles and temperature terms here, right? And you may have already learned that this an square, an square by v square is the pressure correction, nb is the volume correction which you will get. Okay. One thing you can check out, for all the molecules, the value of A would usually always be greater than value of B. See, when it comes to pressure correction, what all factors it depends upon? Number of particles that are attracting in one particle. Suppose if there is any attractive forces, okay, I'll just brief it around and then we'll go ahead. Suppose if a particle is moving, gas particle is moving, the rest of the gas particles are present around it, and they will start attracting this particle if there is an attraction for them. So the amount of attraction on that particle depends upon number of particles, okay, per unit volume. So that would be n by v. And you can see the number of particles, if they are coming in between the path of that particle, that will also decrease the pressure that has to attain on this wall. Okay, so which means we have one more factor, n by v, molar volume, which is also going to decrease the pressure of that particle. So therefore, pressure correction will be proportional to N by V square, or if I remove the proportionality, I'll get it as A N square by V square. Got it? Usually we write this capital N in terms of number of moles only. So we write this as A N square by V square. Anyone has a doubt in here? I'm just briefing it. If anybody wants to understand in detail any part, if you are missing, please let me know.
So this is understood.
Volume correction, usually students make a mistake here. Check out volume correction. Whenever we write PV is equal to nRT, this volume which we are writing, this is called free volume or available volume. Usually in case of ideal gas, the available volume is the entire container's volume. That's why we take this volume as a container volume. But in case of real gases, free volume is always volume of the container minus some real volume, which is the volume of the real gases. So you can see this is like the ideal gas case. So free volume is same as the volume of container. But if the particle size is being defined, and let's say all these particles, if at all I put it at a particular corner, so this much amount of volume cannot be occupied by the other gas particles, then this is the only volume available for the particles to move. So this is the free volume. So free volume would be container volume minus the volume correction. Okay, everyone? Guess all of you understood this point. So while writing the volume correction, right? Now how much amount of this volume which is corrected depends upon how many moles we have. So volume correction will always dependent on number of moles. Okay. So Vc can be written as N into B, where B is some constant. So this is also van der Waals constant. Okay. Now to calculate the value of B, remember this way, that volume of sphere, is definitely not available for the other molecules to hit, as collision is bimolecular, which means if this is one particle and the other particle is coming and colliding it, then for any third particle, this entire volume would be not available during this collision. Okay, this collision can happen from any of this direction. So considering all of these collisions are bimolecular, then the third particle, if it is coming, let's say this is the third particle which it is coming. So this third particle will not have any available volume which is around this. So because it is a bimolecular collision, so ये volume है ना, ये यहाँ तक आ सकता है, but इसके आगे वो उसको volume मिलेगा ही नहीं. So that is all the volume which is covered by these two particles only. Everybody understood that?
Yes, sir.
So therefore, we can say that volume of that sphere, got it? If you see this big sphere which I have drawn, that would be 4 by 3 times of pi into 2r whole cube. So that would be 8 times of 4 by 3 pi r cube. Okay, which means two molecules or two particles are covering 8 times of 4 by 3 pi r cube volume, right? So if it is for one particle or one molecule will have 4 times the volume of the particle covered. This much amount of volume will be occupied. One molecule volume occupied will be equal to 4 times the volume of the particle. So this factor B, which we are defining, right, in van der Waals equation, this is known as excluded volume or co-volume. So which means it is the volume occupied by 1 mole of the real gas. So how much will be that? So B will be equal to 4 times of 4 by 3 pi r cube. This is one particle into Avogadro number 1 mole. So for 1 mole, how much amount of volume that is occupied is called as the co-volume, excluded volume, or just a factor B. This you understood what is B now? So writing the van der Waals equation now, so this is what you will get. Okay. So mathematically, how you have to relate is very important, guys. Check this. Imagine if I write this equation in this format. Okay. What I'm writing it, see, I'm taking this V minus NB to the right hand side, then putting this A n square by V square to the right hand side. So सब कुछ pressure के terms में लिख रहा हूँ. So now check this, how it will vary. Suppose if B increases, check, if B increases here, so ये नीचे का value कम होने लगेगा. So which means V minus NB will decrease. If this value decreases, can I say pressure will increase? Okay, so which means B is related with size and repulsive forces. As we can see, if repulsive forces increases, pressure will increase or no? I guess all of you understood this point. Yeah, this is one very important point, everyone. Okay. Can you relate that mathematically? कोई doubt है? Okay. Now, similarly, check out for A now. Okay. Suppose if you consider the same equation, अगर मैंने A को increase किया, if I increase A, this value will increase, correct? So which means A n square by V square will increase. If that increases, pressure will increase. Sorry, pressure will decrease. ये value subtract हो रहा ना इसमें से, so pressure will decrease, which means A must be related to attractive forces. Because when attractive forces happen, pressure will decrease. Got that? So A will be always related to attractive forces. B would be related to size and repulsive forces. Suppose this was asked in JEE. If you consider A of HCl and A of Cl2, 1 year it was given HCl, 1 year it was given NH3, but both the years it was used Cl2, comparison with Cl2 only. अगर ये दोनों के A को कंपेयर करेंगे तो किसका A ज्यादा रहेगा? HCl का. अभी हमने पढ़ा है HCl will have dipole-dipole interactions, Cl2 will have only London dispersion forces. Which is more dominant? Dipole-dipole. So इसके attractive forces बहुत strong रहेंगे, मतलब उसका A value ज्यादा होना चाहिए. Think you will be able to relate A now? Now suppose if you have to relate A value of chlorine and A value of hydrogen, अब इसमें किसका ज्यादा होगा? दोनों में dispersion forces है. Always remember, dispersion forces depend upon the size of the molecule. जितना ज्यादा size रहेगा, उतना ज्यादा dispersion forces रहेंगे. Got it? So between chlorine and hydrogen, which has bigger size? Chlorine. Okay. In fact, if you remember, F2, Cl2, Br2, and I2, in सब में तो dispersion forces ही है ना? This exists in gas, this exists in gas, this exists in liquid. In fact, this exists in solid. मतलब, see the amount of size. I2 is so bigger in size, got it? Molecule, that the dispersion forces are so high that it will exist in solid state. So dispersion forces can always be directly related with the size. Larger the size, more will be the induction of charges and more will be the attractive forces. So if you were to compare, chlorine and fluorine also, which one will be more? Chlorine would be more. I guess ऐसे questions कर सकते हो आप सब लोग. A को compare करना, B को compare करना आना चाहिए. Now, suppose if you have to compare B, right? Then see, if you are comparing a molecule with an atom, molecule will always dominate. Molecule is like two atoms, right? Two atoms together. So obviously, overall as a molecule size, this is what you will take it as molecule size. While if it is atom, just you will take this as the atom size. So molecule size will always dominate over the atomic size. Next, if you consider B Cl2 and B of H2, here also molecule size will dominate. One important part you can check out is that A value is also dominant for chlorine. B value is also dominant for chlorine. Okay. Again, this came in 2019 JEE mains. A lot of students made a mistake thinking that A value इसका ज़्यादा रहेगा तो B value कम रहेगा. No, no. B's major contribution comes from size. So don't think just repulsion है तो this value would be less. Got it? So B value is more dominant with the size. Okay. Generally check out the units. A will come with this one, A n square by V square, which is a pressure unit with ATM. So that would become ATM and V square will go up. So liter square, mole will come down. So mole inverse, mole square inverse. Okay. Same here. When it comes to B, it is a volume. NB is a volume term, which is liters. So B will be liter per mole. Okay. So remember the units carefully. I guess all of you can do these questions. Next, compressibility factor questions. Compressibility factor, okay, one mistake which commonly we do is how to relate that with volume. First of all, let me define it. Compressibility factor Z is defined as PV by nRT. Now when I write PV by nRT here, what is this nRT by P? Here, this is defined as V real by V ideal for real gases at same number of moles, temperature, then only this is possible, and pressure, sorry, this is P, same number of moles, pressure and temperature. What does that mean? If we have PV by nRT, basically this is for real gases. So this should be written as Z is equal to V real divided by nRT by P real. But like I said, this Z is calculated at same pressure, which means ideal pressure jitna ho, real pressure utna hi ho. Matlab, this I can replace this as ideal pressure also. So nRT by V, that will be ideal volume. That's why you get this equation. So V real by V ideal. Okay. So please remember, we can write it this as P into V real by nRT, right? Or you can write it as V real by V ideal. Just to explain what does that mean, imagine this. There are three cases which we can come across. First, suppose I'm maintaining a real gas and an ideal gas, both at same temperature and pressure. Both of them are maintained at same temperature and pressure. And I'm finding out the real gas has more volume occupied than the ideal gas. Then what should be the Z value? Z should be greater than 1. If second case, same temperature and pressure, if real gas volume is occupied less compared to that of ideal gas, then Z value should be less than 1. If both are same, then Z should be equal to 1. What does this mean? देखो, at same temperature and pressure, for same number of moles, एक गैस वॉल्यूम ज्यादा ऑक्यूपाई कर रहा है. ये तभी हो सकता है तब उनके बीच में आपस में रिपल्शंस हो, पार्टिकल्स के बीच में रिपल्शंस हो, which means here real gas particles will have repulsive forces, while ideal gas will have no forces of attraction. So wherever you find Z is greater than 1, which means repulsive forces are dominant in real gases. If Z is less than 1, attractive forces are dominant. If Z is equal to 1, it will show an ideal gas behavior. I think ये points आपको clear है?
Yeah, sir.
Okay. Just like this, we can also define Z in terms of temperature also. ये एक बार जेई में आया 2004 में, जहाँ पे Z को उसने बोला टेम्परेचर से रिलेट करो. Z, if you relate that with temperature, we can write it as ideal temperature by real temperature. This time volume is constant. Got it? So at constant volume, how you are trying to relate with this? Got it? Which means अभी ये जो increase decrease है ये temperature के respect में लिखा मैंने. Got it? So imagine करो यहाँ पे real temperature ज़्यादा है, ideal temperature कम है. Right? To maintain the same volume and pressure. So if temperature of the real gas is more than the ideal gas, which means attractive forces are dominant here. Got it? And if temperature, sorry, ulta likha maine idhar, is less than the ideal gas, which means attractive forces are dominant here. And if temperature is greater than the real gas for ideal, then that means repulsive forces are dominant here. And ideal gas और real gas दोनों same है, मतलब वो ideal behavior है. Everybody got this point? You can relate Z in terms of volume also. You can relate in terms of temperature also. Okay. Usually when the question comes in terms of compressibility factor, guys, directly आप pressure जो given है ना वही लो. आप ये मत सोचो क्या ये real pressure है या ideal pressure है. दोनों ही सेम होंगे ना, बिकॉज Z को डिफाइन ही ऐसे किया है हमने, दैट इट इज V real by V ideal at constant pressure and temperature, which means same pressure and temperature even for the real gas as well as ideal gas. So whatever the pressure is given, just substitute that, calculate the value of Z. The equation, Van der Waal equation जो हमको है, this Van der Waal equation, I can relate that Van der Waal equation in terms of this equation. See, take this V minus B to the right hand side, take A by V square to the right hand side. So we'll get this pressure term, P is equal to RT by V minus B into A by V square, considering it is for 1 mole. Then multiply both sides with V by RT. Then we'll get PV by RT is equal to this. PV by RT for 1 mole is Z, and I'll get this equation. So if I bring this V down here, I'll get 1 by 1 minus B by V, and 1 minus B by V ka inverse, I'll get an exponential, I'll get a binomial expansion. So if I do the binomial expansion, I'll get this equation. आपने ये किया है Virial's equation, everyone? You will get this equation for sure. First, अब ये जो इक्वेशन है इसमें आपको सिर्फ इतना ध्यान देना है. देखो, इवन इफ यू हैवंट डिराइव इट, दैट इज ओके, जस्ट चेक आउट. यहां से आपको समझना इंपॉर्टेंट है. Virial's equation for Van der Waals equation, Van der Waals equation को Virial form में लिखोगे, you will get this. Now in Virial, what you will find out, this first term is called, whatever the coefficient it has, that is called the first coefficient. 1 by V का जो coefficient है, this is called the second coefficient. 1 by V square का coefficient है, that is called as the third virial coefficient. So you can see second virial coefficient, which is B, can be equal to B minus A by RT. Third coefficient, which is B square. Fourth coefficient, B cube, and so on. So in J, this has been asked like, which of the following is the second virial coefficient or first virial coefficient? So I guess you guys can be able to do this. Next, at low pressure range, got it? If you see how the graphs vary, check out. If the same equation, if this equation, if I operate at low pressure, this volume would be very big. तो ये बड़े-बड़े terms ignore कर सकते हैं हम लोग. So if I ignore that, I will get only this equation. Z is equal to 1 plus B minus A by RT into 1 by V. So Z is equal to, for an ideal gas, Z will be equal to 1. So if I substitute that here, this term will become 0. So B minus A by RT is equal to 0. And TB is equal to A by RB. This is what you will get. So this temperature is what we call it as Boyle's temperature. So as a formula याद कर लेना, Boyle's temperature is A by RB. Got this, everyone? So understand this, it is a temperature when the real gases behave like an ideal gas at low pressure region. Okay. Now if the second virial coefficient is positive, right, this one is positive, B minus ART, if this value is positive, which means Z will be less than 1. If it is negative, z will be greater than 1. देखो इसी formula में check करो. If this is positive, z will be greater than 1. If this value is negative, z will be less than 1. So you can see then attractive forces will dominate here and repulsive forces will dominate here. Okay, so you can see B minus A by RT is less than 0. So T will be less than B and attractive forces will dominate. If A minus A by RT is greater than 1, B is greater than A by RT, T is greater than this, which means repulsive forces will dominate. So in short, you can check out the isotherm this way. This is again asked in JEE once. How to relate these three temperatures. See, the line which almost be parallel to Z is equal to 1 and then slowly increases at higher temperature. This is called the isotherm at Boyle's temperature. Now, any isotherm which you draw which is less than that, correct, which is going negative deviation, that temperature has to be less than boiling point, Boyle's temperature. Anything which is greater than that, it has to be greater than Boyle's temperature. Everybody got that graph now?
Got it.
Right. So in case of hydrogen and helium, how to relate that? See, hydrogen and helium, we know that B value of hydrogen H2 is greater than He because of this is a molecule, this is an atom. So size of molecule will be bigger. So because B is bigger here and this temperature, if you write this line, which means it is definitely greater than Boyle's temperature. Okay. So you know that at room temperature, Z is greater than 1 for both hydrogen and helium, as the repulsive forces will be more dominant. So this is how the graph would be. He and helium, both of them you can check out that. And if you see this P plus A n square by V square into V minus NB is equal to nRT. Here, this part is ignorant. Correct? This part is ignorant here. As you can see that at every pressure, correct, this factor is not at all, attractive forces are not at all being dominant because हमेशा ही वो Boyle's temperature के ऊपर रहेंगे at normal temperatures. So therefore this factor is ignorant. Now if you write in terms of PV here, PV minus PNB is equal to nRT. Divide everything by nRT, then you'll get this. So Z is equal to 1 plus PB by RT. So you can see Z is always greater than 1 in all the cases. So that's why hydrogen or helium के लिए Z calculate करने के लिए you can directly use this formula. Z would be equal to 1 plus PB by RT. Hydrogen helium cases are clear. Now for all generic cases, other than hydrogen and helium, if you take any other generic cases, if you operate at low pressure is up to 60 to 70 atm. At this pressure, this NB value is not dominant. So because the volume occupied by the particles is still sufficiently high. So therefore, P plus A by V square into V is equal to RT. If you can write, you'll get this formula where this implies Z is equal to 1 minus A by RTV. If A increases, Z value will decrease. More dip will be observed. So if you have more dip like this, suppose आपको अगर एग्जाम में ऐसा इक्वेशन दिया है जहां पर 1, 2, 3, 4 ऐसे दिए at one particular pressure आप चेक करोगे. At this pressure you can see the A values. जिसका डिप बहुत ज्यादा है मतलब उसका A value ज्यादा है. You getting it? So this last one, if you check out 1, 2, 3, 4. So A value of 4 will be greater than A value of 3, greater than A value of 2, and greater than A value of 4. So you should be able to do this type of questions. If you have a very large pressure, nearly around 400 to 600 atm, then this A n square, A by V square value which is there, this is ignorant. So P into V minus NB, that you will see it as Z is equal to 1 plus PB by RT. is what you will get. So here Z is always greater than 1 at very high pressures. Got it? And Z is greater than 1 at such high pressures, repulsive forces will be dominant because particles are coming so close to each other that repulsive forces will dominate now.
So what about between 70 and 400?
You will have both the characteristics. Okay.
Okay.
And next, check. In high pressure region, as the pressure increases, Z value will increase. Now, real gases near the room temperature, you can see He and helium will always be on top of it. And all of this N2, O2, CO2, they will all go below this, like this. Okay. And this I've taken it from NCERT. Check out. We can see that at a particular pressure, see how the Z value is varying for both of them. Hydrogen's Z value is always greater than helium. Just now we have learned because its B value is greater than B value of H2 is greater than helium. If you see carbon monoxide and CH4, carbon monoxide will have more Z value compared to that of CH4. Like this, if you consider all the A values and B values, this I have taken it from the data from internet. So for oxygen, we have this A value, nitrogen, methane, carbon dioxide, carbon monoxide, these are all the values. Based on that, this is the order of A value. Okay. Not everything can be explained only on the basis of molar masses. Okay. You have to consider all the factors: molar mass, hydrogen bonding, van der Waals interactions, London dispersion forces, everything. So SO2, molar mass more dominant, then hydrogen bonding. Okay. Then CO2, again molar mass, right? This is more dominant than CH4. CO less molar mass, then all of this. Size, these are all based on size. Right. So that's how you have to check out the A values. Okay. B values completely on the basis of size. Okay. Next, if you check out real gas versus ideal gas, again this is there in NCERT, you can check it out. अच्छे से check करना है यहाँ पर that as you come towards the low pressure region, real gas and ideal gas are almost behaving the same. So can I say that at low pressure and high temperature, real gases behave like ideal gases. Correct? Now check out at high pressure and low temperature, generally, you would see real gases and ideal gas will start having a lot of difference in the volume. थोड़ा volume को ध्यान से check करो. At one particular pressure value, this is the volume of ideal gas. This is the volume of real gas. See, real gas volume is greater than ideal gas volume, which means Z value is greater than 1, which means this is repulsive forces which are dominant. Okay, this graph is more valid for hydrogen. So this was once asked in JEE, relating for which gas it is related and what happens to the Z value near the real gases. So when it is behaving more like a real gases, you can see Z value is more dominant for dead value is greater than 1, which means repulsive forces are dominant here. These are all the questions which were asked as straight statement questions. So I think you should be able to do this now. Everyone, you got an idea now what all things are there? Only one part which is remaining is the Andrews isotherms. All right, that I'll explain you with few questions how to relate that. Now let me take you through certain questions which we were discussing the other day. Where is it? From here you can see these are all the questions from kinetic theory of gases, okay, behavior of real gases, okay, critical pressure gases, and I want you to try the questions from here, section B onwards, all of them now. Right? Should not be leaving any questions because we have almost done all of them here. Check out these few previously asked questions. For instance, ye dekho, how van der Waal behaves, you know, in all of these cases, kinetic theory of gases pe questions. Now, potential energy pe questions that was asked in 2015. Just apply the concept which we have just learned. Okay. Gram's diffusion, we have discussed this, how it is related to molar mass. Next, Virial's coefficient, just now we have done. What is the third Virial coefficient? उसको solve करना आना चाहिए, third Virial coefficient. Critical temperature, ये थोड़ा सा रुक जाओ, बस ये एक क्वेश्चन आप रुक सकते हो, बाकी सब आप कर सकते हो. Boyle's temperature हमने किया है. Okay. Eudiometry, we have done it. Okay. You know how to solve this type of questions, everyone? Yes or no? Guys?
Yes, sir.
Mayank, you know how to
Yes.
solve this? Yes.
Yes.
Right. Those who haven't tried, please try these questions. Okay, comprehension 4. Okay, this was a very good question. देखो इस क्वेश्चन के लिए ही मैंने ऑनेस्टली इतना सा पढ़ा है मीन फ्री पाथ समझने के लिए. ओके, कोलिजन फ्रीक्वेंसी मीन फ्री पाथ बेस्ड क्वेश्चन था जेईई में 2014 में. बहुत ही अच्छा क्वेश्चन है और इस साल भी इसी को रिलेट करते हुए पूछा है. सो यू कैन सी द पैटर्न ऑफ टाइप ऑफ क्वेश्चंस. दिस हैज बीन आस्क्ड अ लॉट ऑफ टाइम्स. या So I want all of you to try this. ये बहुत अच्छा क्वेश्चन है. Next, these are few statement questions, but अब देखो मैट्रिक्स मैचेस बहुत अच्छे से पूछे गए पहले भी. These are the ones which we did discuss. Which case repulsive forces, attractive forces dominant. 2013 का क्वेश्चन है. Okay. This one was also the case. Same thing. Charles law, Boyle's law तो बहुत easy है ये. Got it? Now again the same question has been repeated in JEE. Okay. देखो मैंने बताया था कार्बन ये सब वैल्यूज में क्या चेक करना चाहिए. बी वैल्यूज चेक करना है तो साइज, ए वैल्यूज चेक करना है तो साइज एंड अट्रैक्टिव फोर्सेस. राइट, और इनमें से मैंने एक वैल्यू दी है SO2 सबसे डोमिनेंट है इन सब में से. SO2 देन NH3 देन CO2 देन हीलियम. तो मैंने ऑलरेडी आपको डेटा दिया हुआ है नोट्स में, आप उससे रिलेट करोगे देन कंपेयर विद दिस कॉलम. Right, this is a paragraph which I will explain it completely. Okay, right, so again similar type of question was asked 2007. All right, same type. Basically you have given the pressure and temperature ranges, you have to decide which force will be dominant in all of these cases. Please go through this. This is one very good question, third one. Okay. And yeah, this was asked in 2009. Okay, which is based upon the most probable speed. Okay. 2011, this was a very good question based upon Dalton's law and vapor pressure. This was a regular de Broglie's question. Okay, then diffusion based question. This was very good question in 2016, which is based upon the mean free path. So mean free path का formula के बिना नहीं होगा, ये ध्यान से check करना how it is to be done. Just now I told you that mean free path is proportional to T by P. बस यही relation use करना है यहाँ पर. That's it, guys. इतने सब करने चाहिए सबको. Now, if you have done with this, then I'll be able to help you better in how to, you know, where you are stuck, what are the issues you would get, that I'll be able to help you with. Okay. So if possible, when is the next test for gaseous state, everyone?
The gaseous state test is not in the near future.
Okay, perfect. No issues then. Anyways, but you will finish.
Next class, can you take gaseous state doubts from PACE booklet?
Absolutely. You guys have to submit me first, okay? You have to tell me which are the questions first, okay?
Okay, sir.
Now, please tell me about the paper you were asking, Chaitanya.
Yes, I had doubt in one question, sir. I'm telling